All right, guys, in this video, we're going to be covering some heat capacity as our topic, and I think we got a multiple choice and short answer question. So the first one is multiple choice. We have some data about water, ethanol, solid iron, and we have some heat capacities. Two identical insulated containers held equal masses of liquid at the same temperature. One contains water and one contains ethanol. Two identical cubes of iron are heated to the same temperature. One cube is placed in each container, and both systems are allowed to reach thermal equilibrium. Based on the information in the table below, which of the following best predicts what will be observed? Okay, so basically we had a container of water, and we had a container of ethanol. Okay, they're going to have the same amount of liquid. The containers are exactly the same. They took a metal piece of iron and put them in each of them at a certain temperature. They heated up both iron metals and put them in. So based on heat transfer, right, that heat is going to transfer from the iron metal that's hot to the colder ethanol and water. Without even looking at the answer choices, some things we can predict is one, the temperature change for ethanol should be higher than the temperature change of water. So ethanol is going to get hotter, and then water. That's comparatively, right? Like water is going to get hotter as well, but ethanol is going to get much more hotter. The reason why I know that is the heat capacities of the two. Ethanol has a lower heat capacity than water, which means it's going to take less energy to change temperature. Okay, they're both going to transfer the same amount of temperature, or sorry, same amount of energy or heat from the iron to the liquids. That's the same, but the temperature change is going to be different. That's because ethanol has a lower heat capacity. So let's see our choices. A, both systems will have the final temperature, same final temperature, because the mass and initial temperatures of liquids are the same. That is false, and that is because they have different heat capacities. They're going to have different temperatures as their final temperature. Both systems will have the same final temperature because iron cubes will transfer the same amount of heat to both liquids. This part is true. The iron cubes will transfer the same amount of heat, but that will not mean they will have the same final temperatures. They will have different temperatures because of the different heat capacities. C, the ethanol system will have the higher final temperature because the specific heat capacity of ethanol is lower than that of water. That is true. That is what we were looking for. That is a true statement, and it is a true reasoning. And part D, the ethanol system will have a lower final temperature because the heat capacity of ethanol is lower than water. So the second part is true, the first part is not, and that makes D incorrect. So C is the right answer. Okay, this is just a short answer question. It's basically we're going to be solving for heat. So the specific heat capacity of the solution is 3.4 joules per gram degree Celsius. How much heat is released when 1,000 grams of the solution is cooled off from 85 to 50 degrees Celsius? Okay, we need the equation Q equals M times C times delta T. Okay, Q is for heat, M is for mass, C is for heat capacity, and delta T is temperature. Okay, listing that all off, mass is 1,000 grams. The heat capacity is 3.4 joules per gram degree Celsius, and that joules per gram degree Celsius is important. And finally, delta T. Now, delta T is going to be the final temperature minus the initial temperature. Okay, the final temperature was 50 degrees Celsius because this cooled down. It went from 85 to 50 degrees Celsius. So it is 50 minus 85 degrees Celsius, okay, for a total of 35 degrees Celsius, okay. Don't get tripped up. Sorry, negative 35. I should write negative 35 degrees Celsius because that is final minus initial, and we get a negative number. Okay. Then we just plug in those numbers. So Q equals 1,000 grams times 3.4 joules per gram degree Celsius times negative 35 degrees Celsius. Plugging that all into my calculator, times 3.4 times negative 35. I get Q equals negative 119,000 joules of energy. The reason why it's joules is from my heat capacity here. The grams are going to cancel right here, and the degrees Celsius cancel here, so my answer is left in joules. And that will always be the case with this equation. So it will always work out as long as you are given joules here. Okay, I can also convert this to kilojoules. That's negative 119 kilojoules. For the most part, you could write either answer on the AP test and you should be fine. Always try to get to 3 significant figures. But yeah, so that's how you work heat capacity. Okay.